your table, how would you multiply those things together? Yeah. Oh, yeah, dude. How many of those things?
That's all you want, right?
The bomb. Thank you.
Cause torture.
Yeah. It's not rocket science here, is it?
Yeah.
Got an idea for how to multiply it? Makes sense. You have some idea how would you multiply those two things together? 1 plus 2i.
You're going to program was the best. So.
Would you just multiply the x's, the first by the first? Yeah, that's a great question. I guess that is worth talking about. Should we just go 1 plus 2i times 3 plus I? How should I attack this? With the shotgun? Should I just take this times this plus this times this? Does that feel right?
No.
What feels wrong about that?
The 2i is multiplied by the 3.
You're going to want to FOIL that thing out. You're going to want to use the old FOIL formula. You're going to want to distribute the first to the second to the first. So, go ahead and see what you get. FOIL that thing out. Have people done already?
Oh no.
Go ahead and do it. I'll put them up here. Yeah, I got it. Thank you, Matt. Did you bring your calendar too? Oh, that's good. Not a big. They'll see a lot. Okay, so you guys got it? Working on the algebra part.
One nice square.
So, some people are chugging along here. First thing first, you want to multiply 1 times 3. Then we want to multiply the 1 times I. So what should that be?
I.
Thank you, dude. Sometimes anything is itself. Next one.
6i.
6i.
And the last one?
-1.
Yeah, right. 2i squared, right? Because 2i times I should be 2i squared. But I squared is -1, just like he says. So instead of thinking about this as 2i squared, let's think about it as 2 times -1. Does that make sense? And then we can combine our like terms again. We can take that and rewrite it as 1. 3 plus -2. And we can take these and write them as 7i. Now, I want to show you something kind of interesting that happens when we plot these guys. I'm going to take these guys and I'm going to plot them. And I'm going to represent each one as a line from 0 to the point on the complex plane. And then I'm going to think about the angle between those things, because something kind of interesting happens. So, 1 plus 2i, I had to make these things kind of small, because the product ends up having kind of a large length. So 1 plus 2i is right there. 3 plus 1i, 1, 2, 3. 3 plus 1i is right here. If I multiply those together, I get 1 plus 7i. I get something that's way the heck out here. I'm going to color that a different color. And unfortunately, think I have a protractor with me. John, don't get me into that.
Not this time.
I want a cup of coffee. Well, check this out. If I take, no, you are the man. Look at this from the ground.
Flip it up. Flip it around.
Okay, this first thing has a degree of about, let's call that 20 degrees, and it's upside down. I see what someone was saying. Is everybody good with that? This next one, let's see if we can figure it out. Its angle is more than 20 degrees. Its angle is probably about, what, 63? So this one's about 20 degrees. This is about 63 degrees. This last one, when I figure that out, check out what that angle is. 83. What a trip that is. What a trip that is, if those things work that way. Yeah, it's wild. It's interesting. I'll talk about why that is. So, one other thing, and you'll have to take my word for this. If I take this length and multiply it by this length, I would get this length. So I'm essentially adding the angles and multiplying the two lengths together to get the product. Wild stuff. Wild stuff. The reason for this has to do with trigonometry, and this is why I maybe have 95 before listening to this. But let me write this up here. Multiplying complex numbers. I'm going to write bullet points here. The angles, and I haven't really defined what these are, but I think you get a good idea, are added. And here's another word I haven't defined for you guys. Magnitudes. What's House talking about?
I don't know, Dr. House.
You don't know? Does anyone have a guess? Come on, y'all.
Vectors?
Say what?
The length?
Yeah, absolutely. It makes sense. The magnitude of this, we can think about the magnitude of this complex number as being the length of its vector. Does that make sense? Or the length of it, the distance. If you think about the real numbers, the magnitude of 2 is 2. The absolute value of 2 is 2. The size of 2 is 2. The size of -3, the magnitude of -3 is 3. The magnitude of 3, the size of it, the absolute value of it. With complex numbers, we can also think about their overall magnitude, but we have to think about them as the distance from here to there, the magnitude. So there's a whole bunch of different complex numbers that have the same magnitude. There's 2 real numbers that have the same magnitude, except for 0. But for the complex numbers, there's a whole range of them that have the same magnitude. Okay? So, wow. So we better start thinking about these magnitudes, this idea of what the magnitudes of these things are. Okay, I'm going to try to hustle up a little bit, but this is good stuff. This is important. Here's a general complex number. I'm just going to throw it right out there.